Okay, problem 10.18. Use a change of variable t equals the sine, t equals the sine squared of theta to calculate this integral. Okay, now if t is the sine squared of theta, dt is 2 times the sine of theta times the cosine of theta, d theta, right? And now this integral of the arc sine of the square root of theta dt is let's see, so we have to change the variable, right? The arc sine of the square root of theta is just theta, right? So the square root of theta is the sine of theta, the square root of 2t is the sine of theta, the arc sine of the square root of t is theta, right? So this is the integral of theta, and then you have 2 times sine of theta cosine of theta. This is the sine of 2 theta. And then when t is 0, the sine of theta is 0, so this is 0. And when t is 1, the sine is 1, so this is pi halves. Okay? And so this is this integral, right? Between 0 and 2, and 0, so we have to compute this integral, right? Between 0 and 2 pi of theta, the sine of 2 theta, 2. And this is by parts. We can do this like this, and dv is the sine of 2 theta, and the theta v is minus 1/2 of the cosine of 2 theta. Okay, so this is minus theta divided by 2 cosine of 2 theta between pi over 2 and 0 plus 1/2 of the primitive between 0 and pi over 2 of the cosine of 2 theta. Now this is going to be 1/2 of the sine of 2 theta between pi halves and 0. Okay, so then we have, when this is pi over 2, this is the cosine of pi over 2, which is, so 2 pi over 2, cosine of pi, minus 1 times minus, so this is pi over 4. Okay, and then when theta is 0, this is 0, and then you have plus 1/4, and this integral, this is the sine of 2 pi, the sine of pi is 0, the sine of 0 is 0, so this is pi over 4. Okay, so this integral is pi over 4. Okay, now consider the function, let's part B. Consider the function f is the integral between 0 and the sine squared of x times the arc sine of the square root of t dt plus 0 cosine squared of x times the arc cosine of the square root of t dt, right? And prove that f is a constant, okay, in this interval 0 and pi over 2. Okay, so in order to prove that this is a constant, we have to prove that this is the derivative is 0. Now the derivative of this is the 2 times sine of x cosine of x times the arc sine evaluated at the sine squared, so this is just times x, and then we have plus 2 times the cosine of x minus the sine of x, the arc cosine evaluated at cosine squared, this is x. Okay, so this derivative is 0. So in this interval, it's going to be a constant. What's the value of this constant c? Well, let's look at this and see when we have this interval computed, right? So when the sine squared of 1 is so at pi, let's see, f at pi halves is going to be the integral between 0 and 1 of the arc sine of the square root of t dt plus the integral between 0 and 0 of the arc cosine of the square root of t dt. Now this is 0, and then this is pi over 4. Okay, so the value of this function in this interval is pi over 4.